Next up is going to be Pabi Moloi. She's going to be talking about bringing your Android application to life using animations. Just a brief intro. Pabi describes herself as a young woman in tech. She's currently learning more about Android development after taking a leap from being a .NET software engineer to an Android engineer. She also likes to call herself peckish. She's eager to learn more and hungry for knowledge. So, Pabi, thanks for giving us a talk.
Thank you, Jose. Welcome, everyone. Thank you so much for attending my talk. As Jose said, I am Pabi Moloi. I work at DVT, which is a place for smart people that create smart solutions. And yes, give it up for DVT. And that is my address on social media. I'm on Twitter and Instagram. I'm not on Facebook. Don't know why people are still on Facebook. But anyway, and that's my, honestly don't know why, and that's my website. I try to write a bit about Android and whatever else I learned to try to share with the community. So let's get started. So today I'm going to talk about bringing your Android application to life using animations. So here's a brief overview of how I try to plan out this session. We're going to start with what animations are. This is going to be in general, whether you're doing web or mobile, why we should use animations, how to use animations, and where to use animations. So when we create applications, we really create them to be used solely by ourselves. We want to create applications that are functional and visually appealing. We can achieve those by ensuring that the application works as intended, and the user interface and experience are designed to win the user's trust and confidence. A good user interface and experience design is key to helping users navigate through the journey in your application. As you can see, we have very interesting user interfaces over here, very intriguing and very visually appealing. People interact with our mobile phones every day. Mobile phones have become our go-to devices, from making a call to using your calculator to taking your pictures. Mobile phones have become our go-to devices. People naturally expect some form of feedback when they interact with our mobile phones. So feedback is essential. So how do we provide feedbacks? We can provide feedback by creating messages each and every time a user completes an action. But is this an ebook or is this an app? If we wanted to make users read each and every action out, we'd rather create an ebook for them. Or we could provide animations. So animations, what are they? If you look up the word animations on your Google search bar, this is what you are likely to see. And it says the state of being full of life or vigor, liveliness. So that's what you're trying to do with our applications, give them some life. So animations are often overlooked when it comes to the design process or development process, or are the last step in the design process with user interface and user experience design. So objects respond to our interactions, and people expect a similar level of responsiveness from app elements. Animations add visual cues to notify the user that something is happening in your application. Animations are particularly useful when the UI changes state or when a new action becomes available. So animations should illustrate how elements on your user interface are connected to each other. Unique animations can help you create a recognizable brand. So as I said, feedback is essential. Visual feedback is even more essential on mobile applications. So if you have a GIF, is it GIF or GIF? Okay, I'm gonna call it a GIF. So as you can see, we have a user pressing a button. So we need to try to mimic that on our mobile applications as much as possible, because it's what the user is naturally used to. So we need to mimic that onto our applications. So what Material has is when you click on a button, it has that ripple effect to show that you are actually pressing the button. There's feedback from pressing the button. So functional animations is what I'm going to talk about. So InVision defines functional animations as the types of animations that are subtle and have clear and logical purpose. Good functional animation makes the user interface considerably more appealing and usable. They reduce cognitive load. They help prevent change blindness. Change blindness is when there's a UI state change, maybe from loading from one screen to the next, and the user does not understand what happened in between. So they're a bit lost for the first time they're using the application, like, okay, what's going on? And functional animations help establish a better understanding of spatial relationships. Spatial relationships are how UI elements are related to each other on the UI. So, animation should showcase or infer functionality, provide reassurance. You are at ease when you do something on your application and the animation implying the expected result happens. And they should provide meaning to interactions. So now we're going to talk about Android animations. What we just crossed over is animations in general. You can apply it if you're doing web dev or iOS dev. So I'm going to get into Android animations, and we're going to talk about the view animation framework and the property animation framework. So view animations has been added in the android.view.animation package, and it's been added since the beginning of Android. And these are used to create simple tweened animation and frame-by-frame animation. And here's the link if you would like to just check it out quickly. So tweening is a process of having two intermediate frames, like maybe your first image and your second image, and you create an animation to make it look like the one image is slowly and smoothly morphing into another image. So what's inside this package? It has an interpolator. No, sorry. It is animation.animation listener. And these are the interfaces that can be found there. And it has the interpolator. An interpolator, it defines the rate of change of an animation. I'm sure if you did physics, this might make some sense to you. So the classes that you can find in here are the accelerate interpolator, which is the rate of change that starts slowly and adds slowly, but it accelerates in between, such as when a rocket is launching. It will start slow, speed up, and then stop when it lands. We also have the animation set, which represents a group of animations that should be played together. You have the bounce interpolator, an interpolator where the animation bounces at the end. We have the cycle interpolator, which repeats the animation for a specified number of cycles. And then you have the rotate animator, which controls the rotation of an object. So, and then we have the property animations. What we just spoke about is the view animations. These are property animations. So it's inside the android.animation package, and it's been added since API 11, and there's the reference link on the Android website. So this framework allows you to animate almost anything. It lets you define characteristics of an animation, such as the animator set, which it's a class that plays animator objects in a specified order. You also have repeat count and behavior. Repeat count, how many times you want an animation to run for, and how it should behave, how it should play out. You also have duration, how long you want your animation to go on for. Time interpolation, which defines the rate of change of an animation. And frame fetch delays. So what's inside this package? It has interfaces such as the animator listener, which is a list of, no, it's a listener that receives notification from an animation. You have the transition listener, which is used for starting and ending events of transitions. You have the time interpolator, which defines the rate of change of an animation. And you have the animator update listener, which receives callback on updates of an animation. So, and it has the following classes. There's the animator class, which is a superclass that provides basic animation for your objects. You have the animator set again, which plays a class of animator objects in a specified order. You have the ARGB evaluator. This is used for colors when you want to animate between two colors or a set of colors. You have the object animator, which is a subclass of value animator that provides support of animating specific target objects. And of course, you have the value animator. The object animator is a subclass of the value animator. So the value animator provides a simple timing engine for running animations which calculate estimated values and set them to the target object. So I also like to mention physics-based motion. I've never really played a lot with this framework, so I'm just going to put it in so that you guys can also research a bit more on it, or maybe there's someone that has actually worked with it, and we can discuss that a bit later. So it has the spring animation. You can think of it actually as spring, like a slinky type of spring. And these are physics-based, so there's velocity involved, there's time also involved. So you can think of this as when you're rearranging your icons on your home screen, and you don't put it where it's supposed to be mapped out, it runs back to its normal position. So that's a spring. It goes back that way. You also have the fling animation, and this one you can think of when you're scrolling through your gallery. The faster you scroll, the faster your pictures go. The slower you scroll, the slower your pictures go. So that's the fling. Cool, then I'm going to mention the transition framework. It's also used to animate. So this framework is used to animate layout changes. The previous ones I just mentioned are for objects. This one is for layouts. So this has been added in API level 19, and that's our reference to the documentation on the Android's website. So what's inside this package? The transition framework figures out how to animate starting layout to the ending layout. So maybe moving on from your login screen to your landing screen. Those are two different layouts. So we have the change image transform, and this captures an image view matrix before and after the scene, so it knows how to enlarge it or make it smaller when you're moving between two layouts. You also have the fade, which tracks the visibility of target views from the starting scene to the ending scene. So when you're moving from one layout to the next, it will fade it out. When you have to go back in, it will fade it back in. You also have the explode, which is when a layout will come in from the edges. Instead of coming in all the way in, it will explode onto your layout. You also have the transition inflator, which is used to inflate your transition resource files. These are your XML files. And in the interfaces, we have the transition listener. So yeah, I think that's it. It literally has one interface. So let us animate. So if you would like to animate a bell, for example, I've always wondered how this is done. So here we define a rotate tag. And don't have to worry about the schema. We set its duration to 9 seconds. Is it 9 seconds? 12.9 seconds. We give it degrees. And we give it the pivot X and pivot Y. The repeat count, we want it to go 10 times, and the repeat mode is reverse, because we want it to keep playing. If it finishes its animation, it must start from the ending point back to the starting point if it's in reverse. So, and this is how you would do it in code. To play it actually in the code. So you define an animation object we call it shake. You use your animation utils, which is a class that defines common utilities for working with animations. And we call the load animation method, which loads an animation object from a resource. And we give it a context of this. And the r.anim.bell is our resource file, XML file, that is in the animation package. And we say, image view bell, start animation, we pass it the shake. So that's how we get to the animation playing. So if hypnosis is your thing, animations can help you hypnotize people. So this is literally just an image view, and I applied some animations onto it to make it rotate. So let's see how I actually achieved this. So I used a method that is found in the android.animation package, and this is the offload method. So let's see what it takes. It takes a target, which is the object you want to animate. The property is the attribute of an object that you want to animate. The values is an array of values that you want it to animate from. So if you can have a starting value, an end value, and values in between, and it will play out all those values. So the property that we'll be animating is the rotation, which is found in the Android rotation package there. And then how we do it in code is we I called it a hypnosis animator of the type object animator. Offload, I passed it in. The target is image value.hypnosis, which is our image view. Rotation is the target we want to animate from 0 degrees to 360 degrees, so it's a full circle. And we say hypnosis animator duration, we give it 10 seconds, and then we say animation start. And this is what we get after doing that. So if you want to launch rockets, animations can actually help you. No need to go through NASA or anything. Like, animations can help you with that. So let's see how we achieve this. So the target that will be animating, which is the attribute of an object, is the translation Y. As you can see, it's going up the Y-axis. Cool. Fine, we'll create an object of type object animator. We call the float method. We pass it in our rocket. Translation Y, as I just said. From 0 to minus screen height. Minus screen height is saying you want it to go off the screen. It must disappear from the screen. We say duration is 5 seconds, and we get it to start. And we have that result over there. But the problem with this is we're leaving our dog behind. I'd like to think dogs will also like to go to space. So let's see how no, honestly, if we want to go to space, I'm sure all the animals on Earth would like to also explore. So let's see how we can make sure our doggo goes on to space with us. Cool. So here we're going to use update listeners. Like I mentioned, it has listeners. So we give it a value animation of offload again. We want it to go off the screen, launching our rocket, and we add an update listener to it. We specify our rocket on our dog. We give it translation. We want both of them to go up the y-axis, and we give it a value. And we create an animator set. I'd like to recap. Animator set is it plays your animations in a specified order. You can play them together in sequence or one after the other or after a specified delay. So we pass it our position animator. We set it at duration, and we say start. And then, therefore, we can have our dog go to space with us. You can also make our rockets go to space, and then come back to Earth. So this is how we do it. We create and we use the offload method again. We give it an update listener. Is it the same? No, yeah, it's the same. Yeah. And we also pass our rocket and our dog. So, and then we're going to do it a repeat mode. Remember, it went up and it came back down to Earth. So it has to repeat its animation, but in reverse. So if the animation, the end value is up, it's going to play from the up value to the starting value. So repeat count, we want it to go 3 times and give it a duration, and we say animation start maybe on an on-click of a button or on-click of a screen. And that's how we do it for setting it up. And then, yeah, I think this is the same. Yeah. So add update listener as a set of listeners to the set of, as a listener to a set of listeners that are sent updates through the life of an animation. So yeah, I'll get into listeners a bit more. So how do we apply animations in our everyday apps? The animations we just saw are not really practical for the apps that people use on a daily basis. So how do we apply the principles and the packages behind that in our application? So I created a simple application, Android application. It's a makeup app. You have your landing screen over there. You have your sign-in and your sign-up screens. You have your product or brands view. You click on one of them, it will show you the blushes, and you click on whatever category of type of blush you want to see, it will open a list of that app. So to create this app, I made use of the Makeup API. I'll tweet the API to you guys. I didn't add it into my slides. So this is one of the animations. When you click on sign up, the screen slides up. So I defined this in a slide up XML. So let's open up that quickly so I can show you how I did it. Yeah. There we go. And the cool thing about animations is you can do it programmatically or you can do it through your XML files. So here, I gave it a duration from Y delta to Y delta. So it's your Y-axis again, from value to value. We gave it the duration of the alpha is it changing color. This is fading in and fading out. It has to change color. And then, yeah, and that's how we get to that animation. Cool. And then the next one is when you click the back button, it has to come back down. So if a screen went up when you were navigating to it, it should naturally come back down if you're going back into it. So I defined this in the slide down XML. Let's see what that file looks like. It looks similar to the slide up XML, but this time the thing that changed are the Y delta values. So you want it to come back down. So let's compare them. So it starts from 100 to 0, and then from here it starts from 0 and then to minus 100. And that's how you would animate your layout. And to apply this layout, you go to your activity that is going to use the layout, and you call override pending transition. This is used to play out the values that you want to animate through your layout, and you pass it the slide up and the slide down. You also need to specify it in your manifest. I forgot to have my manifest open for you guys. There we go. No, sorry, not the manifest, the styles. The styles. There we go. So if you want to define your animations globally for your layouts, you go into your styles, you say window activity transition is true, and you give it the enter animation is a slide up. So when you enter into a layout, it must slide up, and when you exit, it must slide down. So yeah, let's go back to our slides. It's open for you guys, awesome. And then what I also have is sharing an image between views. So as you can see, when you click on one of the products, you click on that image over there, and it inflates into a bigger image. So for this, I use the change image transform. Now this transition captures an image matrix before and after the scene change. So this is fairly simple on how you use it. You create an XML, you literally just call this method over here. And this is defined in your transition package, and you plug it in there. You also have your animation package, which has all your animations. Cool. My slides open. There we go. So the next screen is the shimmer views. I'm sure you guys have seen this, and this is just to sort of like get away from your traditional progress loader, where when the content is loading, you give the user a view of how the content is going to be displayed. So you create shimmer views, and it will display once the content is available. So this is how I created it. There we go, in here. I called it recycler shimmer adapter. I created a function called animate recycler views. I gave it a target, which is the object I want to animate, and the property is the attribute of the object I'd like to animate. So I made use of the object animator class, and I used the method of object, and I pass it the target, the property, which I'll pass from here, ARGB evaluator, which we saw earlier is used to animate between different colors, and I say animate from white to gray. So on my view holder, I call this method, I pass it the string and its property, which is the background color of your text view. And that is how we get that. And that's how we get this little, that's how we get that little animation playing. So, yeah, this is the method that I used. So you guys can see its definition, which is the target, the property, the type evaluator, which is the ARGB evaluator, and the values it should animate in between. I also, for maybe tracking your order, it's an e-commerce application, so when you buy something online, the first thing you do is check my order, right? Even after paying, you will check my order. So I created this little animation here so you can see where the order is. So our order over here left our couriers and it's on our way. So I define this in my code, and I say we use offload method again. We give it an image view truck. We say translation X. As you can see, it's moving along the X-axis. And we give it a duration of 5 seconds, and we say object animator start. So which framework should you use? When should you use animations, and where? So our view animation framework only animates view objects. So if you want to animate non-view objects, this package would not really be ideal for your case. Few aspects of a view object are exposed. So you're only exposed to the rotation, the scaling, making it bigger and smaller, and not the background color, for example. So, but it is less time to set up, and you write less code for it. Whereas for our property animation framework, you can animate any property of literally any object. The actual object is actually modified. So if you were not to use this framework and you're animating, and let's say you are moving a button when a user enters your screen, the on-click of that button is where the button was, not where it is now. Am I making sense? Cool. So, and it is a robust framework because you can assign animators to the property you would like to animate, such as the color. So what are some of the drawbacks of using this, of animations in general? You cannot use it on text views. It is suggested that you do not animate text views, because what it does is it will jump to a new position before it finishes to animate. As this example, I have a make me smaller text. You try to make it smaller, it jumps to a different position before it completes its animation. So it is not wise to create animations to text views or views that contain animations. The adaptive view. Some of the subclasses of an adaptive view include a list view, a grid view, a spinner, and a gallery. So all these subclasses use an adapter. So adapter is used to load your data onto your views. So animating these views may cause your device to actually hang. So you will try to apply animations onto these and your screen will just stop. So because these subclasses manage their own child views, so you're confusing the whole application. And the surface view. Has anyone worked with surface view before? What did you use it for? Camera. I've never used it before, but I thought I should mention it in case someone has used it in the room. So a surface view, for those who don't know, is dedicated to drawing surfaces on a view. So instances of a surface view are updated from a non-UI thread. That's why you cannot apply animations to it, because updates will be out of sync, so it will not look properly. So here are some of the references that I feel like we can all look at before we try implementing animations. We have the Material Design Understanding Motion, which teaches you how to understand motion and how you should apply motion. We have the Android Animation Library. That's the link over there. And our Android record demos can be found with that tutorial with Kotlin. And functional animations, you can just go to Envision app for more details. And some of the images that I used, the references are there. UpLabs is a really great place to go when you're looking for inspiration. You can also take part, submit some of the work that you have done. Very amazing community over there. So yeah, that's it. Thank you, guys. Thank you very much.